Hello, welcome to Learn with Lakineni. Now in this session, I am going to explain the various methods available in the Numpy. In the previous sessions, I have explained so many concepts regarding Numpy. What are the various ways of creating Numpy, and also what are the various ways of creating random data with the help of random module, np.random module. In this lecture also, I will cover various Numpy methods. Before watching my video, please subscribe to Learn with Lakineni so that you will get more updates from my channel. Please subscribe to Learn with Lakineni. Okay, in this lecture we will learn about the very important methods of view and copy. So there are two more methods in Numpy. Those are view and copy. View, with the help of view and copy, we can create another array, another n-dimensional array. That means view, the basic information of view is different, the importance of view is different, and the importance of copy is different. Here the view function, suppose if you see, today we are going to learn about view method. The importance of view method is, if you have any array, if you want to see the array in another form, you can give a name and you can see both the arrays with the help of a view. Suppose here I am creating a Numpy array. A is equal to np dot array. Suppose I am creating a one-dimensional array 10, 20, 30, 40, some 50. So this is an array. Here I have created an array. Okay. Now I am writing the view as B. I am creating another array. B is equal to a dot view. So here the view method is not creating a new array. The view method is showing the same array in another name. So whatever the array A is, whatever the array object A is showing, the same object will be shown by V. So V is not creating a separate copy. View is showing the same array with another name B. Suppose if you execute this, sorry, here I have to import Numpy as NP. Basically import Numpy as NP. Okay, so here I have created a array. Suppose if I see, if I print A, so what it is printed? It is printed 10, 20, 30, 40, 50. Suppose if I print B, so B also showing the same elements A, 10, 20, 30, 40, 50. So usually we will think that a separate Numpy array was created with the help of U. But here a separate Numpy array was not created. Here A and B are showing the same object. So that means if you do any changes for the original array, so those changes will be reflected to B. If you do any changes to B, those changes will be reflected to A. Suppose that means suppose here I have created an array A, and also I have created B is equal to A dot view. That means you want to view A in with another name B. That means what is the A object? What A contains? A contains 10, 20, 30, 40, 50. This object is shown by A. In the same manner, whenever you are creating a view of A, so B is also showing the same object. That means whatever the changes you made to this object, those changes will be reflected to both for A and B also. Okay, we will see with practical example. Suppose here I am writing, suppose here I want to modify the first element, the element at index 1. So F1 is equal to, suppose if I write 999. See here, run the I have run the code, and now you can see after running the code here, the value here, the value at index 1 is 20. Here now it is changed to 999. Now I have not changed, I have not modified any value in B. Now I want to see print B. So you can see the same change has reflected to B also. So here I have changed the A, the value in the array A, but the same reflection has happened to B also. That means A and B are not same. A and B are both pointing to the same object. So that is the purpose of view. So you can see, suppose if you do any modification with B, suppose if I want to change the element at index 3 with some triplet, Now if you see B, so the element at index 3 is replaced with triplet. Now if you want to print A, so the same reflections has updated on A also. That means A and B are not different objects. Both are showing to the same object. So that is the advantage of A. So this can be applied for either 2-dimensional array or 3-dimensional array. Whatever it may be the dimension, if you create a view of an array and if you store the view in another array, another object, both objects will show the same object. Similarly, you have another method called as copy method. So copy method always creates a separate copy of the original array. Suppose in the view you are not created any separate copy. So here a view means simply another name you have given to your original array. But when it comes to the copy, a separate copy will be created. That means a separate object will be created. So if you perform any changes to the original array, those changes won't be reflected to the copy array. Okay. That means by using copy method of ND array class, we are creating another copy of the existing ND array. That means we are creating another copy. Not we are not showing the same object. Suppose if you write, suppose if you have A is equal to np dot array of A is in square brackets. I am creating 1, 2, 3, 4, 5, 6. Let us suppose this is an array. Suppose if you print array A is printed. Suppose if you write B is equal to A dot copy, then if you run this, suppose if you see A, the same thing will be printed. If you see B, the same thing printed. But if you made any changes, suppose if I write A of 2 is equal to A triple 3, then if you print A, 3 is, that means the element at index 2 is replaced with 3. Suppose if I write if I see B, there is no reflection in the B. So whatever the changes you have made to the original array A, those changes have not reflected to the B, because A and B objects are not same. So in this, whatever the objects is there in whatever the object is A, in this similar manner, B object is created with the same content. So whatever is the changes you made to the A, those changes won't be reflected to the Numpy array B. Okay. Similarly, suppose if you make any changes, suppose I want to change the element at index 4 with the 444. Now, if you see B, so the element at location 4 is changed. Suppose if you see A, so the change is not reflected to A. That means both are not the same. The A object is different and B object is different. That means copy is creating a separate copy, separate object. View is not creating a separate object. So you can view is just another name to the original array. Both are referring to the same object. So that is the information about what is a copy method and what is a view method in the Numpy array. Now another important method in Numpy is reshape. Reshape is a method. With the help of reshape, you can reshape. That means you can rearrange the elements. That means if you take 1-dimensional array and if you want to convert it into a 2-dimensional array, you can convert. Suppose if you take a two-dimensional array and if you want to make it into a three-dimensional array, yes, you can convert. So you can reshape. Okay, that means you can convert a one-dimensional array into a two-dimensional array or three-dimensional array with the proper number of elements. So reshape will have reshape. We can apply the reshape only if we have sufficient number of elements to transfer from one dimension to the another dimension. Otherwise, reshape won't be accepted. Suppose if you take, suppose I have a one-dimensional array. In that one-dimensional array, I have 12 elements. Now I want to convert this one-dimensional array into two-dimensional array of size, of shape 3 by 4. That means I want 3 rows and 4 columns. I want 3 rows and 4 columns. Now 3 rows and 4 columns. Now 3 rows and 4 columns means how many elements you want? You want 12 elements. So how many elements at your hand? You have 12 elements in your one-dimensional array. So definitely you can convert a one-dimensional array of 12 elements into a two-dimensional array of size 3 by 4. So 3 by 4 array requires 12 elements. So you are having 12 elements at your hand in the one-dimensional array. So definitely it is possible. Suppose if we have one-dimensional array of size 10 elements. Now you want to create a two-dimensional array of size 3 by 4. So here you have 10 elements, but you want an array size of 3 by 4. That means 12 elements. How can you convert a 12 elements into the size of 10 elements into the size of 12 elements? At your hand you have 10 elements. Now you want a size of 12 elements. So it is not possible. So it will show you an error. That means when you are converting, the number of elements should be same. Otherwise, you will get an error. So that is a advantage with the reshape. Reshape can be converted. Reshape can be used to convert one dimension to another dimension. Suppose I have 12 elements in one dimensional array. I want to convert into this one dimension into 2D array. But I know while converting into two-dimensional array, I know the number of rows, but I don't know the number of columns. So you can put 3, minus 1. So here 3 is a row number of rows. Here I don't know the number of columns. If you don't know the number of columns, you can immediately put minus 1. Then reshape method will automatically calculate from you have 12 elements in the one-dimensional array. Now you want 3 rows. So how many columns will come? 4 columns will come. So even though you are not giving the number of columns, it will replace the number of columns with 4. So if you don't give both the numbers, it cannot reshape. You have to give either row number or column number. So the rest of the either column or row, it will be calculated. Suppose I have 12 elements. Of one-dimensional array. I want to convert this one-dimensional array into two-dimensional array. I don't know the number of rows, but I know the number of columns. Then it can easily calculate that the number of rows are 4. How? So you have 12 elements. The number of columns are 3. So how many rows will come? 4 rows. So 4 by 3 is equal to 12 elements. That means it is a two-dimensional array. Okay. So that estimation can be done by reshape if one either column or row count is missing, but both are missing, it cannot do. So if any one is missing, you can put in that place as minus 1. Now we will see how reshape will work. So now here I am taking a Numpy array. A is equal to np dot. I want to create 12 elements. I am creating the 12 elements with the help of a range so that I can quickly create the numbers. A range 1, 13. That means I want to create a Numpy array of 12 elements from 1 to 12. Okay. So here I have created a Numpy array. Suppose if I execute this, so how many elements are there? 12 elements are there. So how can you know that 12 elements? A dot size. If you press A dot size, it is giving 12 elements. Now I want to reshape the array A. So B is equal to A dot reshape. A dot reshape of I want to convert this one dimensional array into size 3 by 4. That means two dimensional array of size 3 by 4. If I execute B, so it is giving a two dimensional array of size 3 by 4. Okay. So if suppose I don't know the number of columns, but I know the number of rows which I want to create. So here you can write A dot reshape of, I know the number of rows are 4, but I don't know the number of columns. Then also it is giving an array. It is reshaped your original array into another array C with a shape 4 by 3. That means 4 number of rows you want. So even though you are not mentioning the number of columns, it calculates the required number of columns and it will adjust the given array into the required array 4 by 3. Okay. Suppose I don't know the number of rows, but I know the number of columns. So then also you can write A dot reshape of here I am writing I don't know the number of rows. So here if you don't know the number of rows, it is giving you, I am putting -1. I know the number of columns. Now I am executing the D. So even though you are not giving the number of rows, if you know the number of columns, then it automatically evaluates that the number of rows are 4. So it is giving a two-dimensional array of size 4 by 3. So here I have mentioned only columns. This is columns, but I don't know the rows. So if you don't know the rows, you just put -1. So here I kept the value of columns. Then it automatically calculates the number of rows are 4. The shape of the array is 4 by 3. You got the shape of the array is 4 by 3. Okay. Suppose if you ask that, sir, what happens if you don't give the both values of rows and columns? So A dot reshape of here I am giving, I don't know the rows, I don't know the columns. Okay. Then you can see, can only specify one unknown dimension. That means you can specify either one unknown dimension, either row dimension or column dimension. If you put both as unknown, it will give you an error. If you don't give both the what is called dimensions, then how can it create a reshaped array? So either one dimension has to be included, either row or column. If row knows, you put the row number of rows and you put the column as -1. If you know the number of columns, you put the row as -1. Then it definitely creates a reshaped array. So this is the advantage and this is the way of using the reshape. Okay. Similarly, if you want to create a 3-dimensional array, you can create a 3-dimensional array also. Suppose I have elements A is equal to np dot a range of 1 comma 25. That means 1 to 24. 1 to 24 elements will be created. That means if you print A, how many elements are created? 1 to 24. If you know the size, A dot size 24 elements are there. Now I want to reshape this into a 3-dimensional array. So A dot reshape. Suppose I want to create a two-dimensional array in which every 2-dimensional array has 3 rows and 4 columns. That means 2 into 3 is. So how many elements at your hand? At your hand, 24 elements are there. So 24 elements are there. Now what is the size you want? 2 comma. You want to convert this 1-dimensional 24 elements into a 3D array. So what is the size of the 3D array? 2 comma 3 comma 4. That means 2 into 3 into 4. So how many elements? 24 elements are there. So here you have 24 elements. You can comfortably, happily, you can convert 24 element 1-dimensional array into 24 element 2-dimensional, 3-dimensional array. So now if you execute this code, so what happens? It has created a three-dimensional array. So in this also, if you don't know one dimension, that means either rows or columns or the 2D index, then definitely you can put that value as -1. Even though you are giving the value as -1, it will print. Okay. Suppose c is equal to a dot reshape. I don't know. I know the number of rows, I know the number of columns, but I don't know the index. Okay. So here first 2 is the which two-dimensional array? How many two-dimensional arrays are there? What is the second? What is the 3? How many one-dimensional arrays are there in the two-dimensional array? What is -1? Here I have not mentioned the number of columns in the one-dimensional array. So here simply I put -1. So now in this case also you have created successfully the three-dimensional array. So if one is unknown, if out of 3 dimensions, if one dimension is unknown, definitely you can calculate the unknown dimension with the known 2 dimensions. Here you know the 2 dimensions. Here you know this is one dimension, this is one dimension. With the help of these two known dimensions, definitely you can find out the unknown dimensions. Okay. So this is the way of using the reshape method. Another important method is after reshape is resize. The resize method is there. Here this is not. So resize method. What resize method is doing? We have reshape. When you want to reshape an array into another array, the number of elements should be matched to that reshaped array. Suppose I have a one-dimensional array of 12 elements. I want to reshape it to 3 by 4. That means the number of elements required is 12. So here in the one-dimensional array I have 12 elements. In the reshaped array also I have to fill with 12 elements. So it is matched so that you can apply the reshape. Suppose if the number of elements are not matched, not sufficient, that means if you then after reshaping the number of elements are larger than the required elements, then reshape won't work. It will give you an error. Suppose I will show how you will get an error. Suppose here I have an array a dot a range of 1 comma 11. That means it gives 10 elements. If you see, it gives you 10 elements. Now I want to reshape it to a dot reshape of 3 by 4. Reshape it to 3 by 4. So what it is saying? Cannot reshape. It is saying that cannot reshape array of size 10 into shape to 3 by 4. Why? Because 3 by 4 requires 12 elements. So you cannot accommodate 10 elements into a larger array of 12 elements. So that's why you are getting the error. When if you see the case of resize, you will not get any error even though the number of elements are not sufficient. So that is the advantage with the reshape. What reshape is doing? The reshape function is used to create a new array with specified shape. If the new array is larger than the original array, then the new array is filled with the repeated elements from A. Okay, repeated elements from A. So here I'll show manually. See, suppose I have an array. A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is how many elements you are having? You are having 10 elements. Now I want to reshape this array of size 3 by 4. That means I want 3 rows and 4 columns. So how many elements you require for 3 rows and 4 columns? You require 12 elements. So here this is the 3 rows and you have 4 columns. 1, 2, 3, 4. Now here you have elements 10, but you require 12 elements. First resize won't give you any error. Initially it fills with the given elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Still you require 2 more elements. Now it fills the remaining elements with the repeated elements from the given array. So here this 1 and 2 will be filled. Like that it fills the array and it converts the array into the required shape, but it don't give any error if the elements are not sufficient and the new array is larger than the original array. Simply the new array is filled with the repeated copies of A. Okay, let us see an example. Here I have a array A is equal to np dot a range of 1, 11. So how many elements are created? 10 elements will be created. Okay, now I want to resize this array as np dot resize. The method name is resize. For the resize method you have to supply the array. Now I want to resize it to 3, 4. I want to reshape it to 3, 4. So here you can see that I have 10 elements, but I want to reshape it into 3 by 4, but I didn't get any error. Simply it converted the array into 3 by 4. So first 10 elements are distributed along the rows and columns. Here still the gap is 2. Still you are insufficient of 2 elements. Now it repeated the 2 elements and it is filled up those 2 elements in the empty blocks. Okay, these 2 are repeated here. So this is the way of using the resize method. So resize method won't give you any error. It will fill the remaining elements repeatedly in the insufficient locations. Here I have taken an array A is equal to np dot array. Here I have created a 2-dimensional array with 2 rows and 2 columns. So what is the 2-dimensional array? Here the 2-dimensional array is 1, 2, 3, 4. Okay, now if you print A, so it is showing the 2-dimensional array. Now I want to reshape it into np dot resize of, I am passing the original array, 2, 3. That means 2, 3. How many elements you want? 6 elements. You want to make it a 2 by 3 array. So what is the array you have? You have an array of size 2 by 2. Now you want an array size of 2 by 6. Array of 2 by 2 requires 4 elements. Array of 2 by 3 requires 6 elements. How many elements we are having? We are having only 4 elements. Now you want to resize it to 2 by 3. So this is the 2 by 3 array. So how many elements you have? 4 elements. Initially these 4 elements will be distributed like this here in this array. So here still you have 2 empty places. These 2 empty places will be filled with 1 and 2. Okay, so the same output you got here. So here the 2 vacant positions are filled with these 2 values at here. Okay, so this is the way of creating the another way of creating the numpy array and changing the shape of your numpy array with the help of resize. Reshape will give you the error if the number of elements are not sufficient to change the shape. Here resize won't give any error even if the number of elements are not sufficient to resize it, because whatever the deficiency is there, those deficient elements will be replaced with the repeated elements from the given array. So another thing which I want to explain about reshape is here. Suppose here I am giving A is equal to, I am creating a numpy array np dot a range of 1, suppose 11, 1, 12. That means 1, 13. That means 1 to 12 elements will be printed. Now I want to reshape it to B is equal to A dot reshape, A dot reshape. So what is the shape you want? Let us suppose I want 3 by 4. I want 3 by 4. Okay. Now if you print B, so how the elements are distributed? The elements in the reshaped array are distributed as row measure order. That means initially first row will be filled. Here 1, 2, 3, 4. That means first row is filled. After filling the first row, now the second row is filled. After filling the second row, third row is filled. By default, when you want to reshape, it will follow row measure order. Row measure order. By default, it will follow row measure order. Okay. Suppose if you want to fill like this, you want to fill the elements of size 3 by 4 in the column measure order. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is called as a column measure order. If you want to reshape the elements like this, then you have to mention the order as you have a attribute. You have one attribute in the reshape method, that is order. You have to put this one. I will put the shape in square in brackets, comma. Here I will put order is equal to capital F. That means I want a column measure order. I want to print a column measure order. Okay. Now you can see the elements are arranged into a shape of 3 by 4 basing on the column measure order. You can see first 1, 2, 3. Later first column is filled. Later second column is filled. Later third column is filled. Later fourth column is filled. So this is the way of using the order attribute in the reshape method. If you don't mention order is equal to F, so initially by default all the elements are reshaped by basing on the row measure order. If you mention order is equal to false, then elements will be filled basing on the column measure order. Here one more method is there, that is flatten method. Flatten method. So here one more method is there, flatten method. So this flatten method always converts any n-dimensional array into one-dimensional array. Suppose if you want to convert a 3-dimensional array into one-dimensional array, that means it is flattening into, it is making the 2-dimensional or 3-dimensional, any multi-dimensional into a single-dimensional array. So if you want to keep all elements into a single one-dimensional array, you can use the Numpy flatten method, which keeps any dimension into one-dimensional array. Suppose I am taking a one dimension. Suppose I have taken A is equal to NP dot A range of 1, 13. That is 12 elements are there. Now I am reshaping this array into 3 by 4. That means I have 12 elements. I can convert into a reshape of 3 by 4. Now it is a 2-dimensional array. Now if you want to make this 2-dimensional array into a 1-dimensional array, you can simply do like this. B is equal to A dot flatten of A dot flatten. Now if you print B, you can see the 2-dimensional array A becomes a 1-dimensional array. Okay, so like this you can create any element, any n-dimensional array into 1-dimensional array with the help of flatten method. So here usually flatten method follows row measure order. That means when you are converting an n-dimensional array into a 1-dimensional array, using the flattened method, it follows by default the row measure order. That means first these elements will be written 1, 2, 3, 4. After that, the next row elements will be written. So 5, 6, 7, 8. After that, 9, 10, 11, 12. Like this, it will flatten the any dimensional array into one dimensional array. Suppose if you want to print like this, first column column measure order 1, 5, 9, 2, 6, 10, 3, 7, 11, 4, 8, 12. Then you have to use an attribute called order called F. That means you don't want row measure order, you want column measure order. So if you want like that, then you can write the code like this. Suppose C is equal to a dot flatten here within quotations you keep capital F. That means I want to make a row measure order as false. That means I want to print the elements. I want to consider the elements as from the column measure order. Suppose if you write, you can see how the elements are printed. The column elements are printed first. So this is the first column, and this is the first column, and second column, third column, fourth column. So in this manner, the elements are printed. So you can see this is the first column. These are the elements of first column. These are the elements of the second column, third column, fourth column. So if you put within quotations capital F, then it will by default consider column measure order. Otherwise, it will consider row measure order. Okay. So this is a way of using the flatten method, which is available in the Numpy.